All right, today we're heading to the Kenyan coast to check out the incredible sand dunes of Mambrui. Now picture this, a place that looks like a full-blown desert one season, and then it's just a gentle coastline the next. It's this dynamic, kind of mysterious, and absolutely fascinating landscape. And you know what? We're going to figure out exactly how it works. So, this is the central puzzle, right? How can a landscape change that dramatically? Why do these massive, enormous dunes just appear, only to basically vanish as the year goes on? It's a mystery written right there in the sand. And the clues? Well, they're in the wind, the water, and the shape of the land itself. Okay, so here's our game plan. First, we'll dive into the mystery itself. Then we'll look at the battle of the winds that shape this coast. We're going to find out where all that sand comes from, see how the geography is the final piece of the puzzle, and wrap up by looking at why these dunes matter so much. So, first up, the seaside mystery. What's happening at Mambrui is, well, it's pretty wild. You've got a place that basically acts like a desert, sitting right next to the Indian Ocean, but only for part of the year. And get this, large-scale dune systems like this one that literally appear and disappear with the seasons, they're super rare, globally. These are not permanent fixtures. So you really have to think of these dunes less like static hills and more like living, breathing sculptures. They get built up and then kind of erased year after year, all carved by these powerful, ancient wind patterns. They're a direct reflection of the planet's natural rhythms, and if we can understand them, we can understand the engines that drive this entire coastal system. All right, so to solve this mystery, we've got to meet the two main players. This entire coastal drama, you could say, is directed by two really powerful seasonal wind systems. You might have heard of them, the monsoons. And you can see the contrast right here. On one side, you've got the Kaskazi, which is the northeast monsoon. This one blows from about October to March, and it's strong, persistent. This is our dune builder. Then, on the other side, you've got the Kusi, the southwest monsoon. It brings the rain from April to September, but, and this is key, its winds are way weaker. This difference, this asymmetry, is absolutely crucial. And look, this isn't just a casual observation. This is backed up by science. As Dr. Muhammad Ahmed, a coastal geomorphologist, explains, the sheer strength of that northeast monsoon is what gives it the power to literally move mountains of sand from the beach inland. The weaker Kulisi, it just doesn't have that kind of muscle. Okay, so we have our powerful construction crew. That's the Kaskazi wind. But you know, every builder needs materials. Where in the world does all this sand, we're talking tons and tons of it, actually come from? Well, the answer lies just a little ways up the coast, the Sabaki River. This is Kenya's second longest river, and it travels for hundreds of miles, basically acting like a giant conveyor belt, collecting sand and silt the whole way. And then, it dumps this massive load of sediment right into the Indian Ocean. It's like a giant stockpile of building material just sitting there, waiting for the winds to show up. And this brings us to the final piece of the puzzle. We've got the strong winds, we've got the sand, now we just need the perfect spot for them to meet. And it turns out, Mambrui's very specific geography creates the perfect stage for this whole spectacle. So, to understand why Mambrui is the perfect spot, we need to talk about something called longshore drift. The key word to remember here is angle. See, those strong northeast winds? They don't just hit the shore straight on. They come in at an angle, and that creates a current. Basically, it's like a conveyor belt that pushes all that sand from the river along the coast in one specific direction. Okay, let's put all the pieces together. Step 1. The Sabaki River delivers tons and tons of sand to the coast. Step 2. The strong Kaskazi winds show up, hitting the coast at an angle. Step 3. This kicks off longshore drift, which starts pushing all that sand northward along the shore. And then, Step 4, this is the magic ingredient, the coastline at Mambrui has the specific curve that acts like a natural trap, catching all that moving sand and causing it to pile up into these massive dunes. You know, this also perfectly explains why the nearby town of Malindi doesn't have these dunes. Think about it. It's south of the river, so that conveyor belt of sand, it's moving away from Malindi, not towards it. Plus, the coastline there has a totally different shape. It just doesn't have that perfect storm of conditions coming together. Okay, so we've cracked the mystery of how these dunes form, but now let's talk about why they matter. Because these aren't just some geological curiosity. They're a really vital part of the coastal story, and they're deeply connected to the environment and, of course, the local communities who live here. And the scale of this transformation is just
staggering. I mean, during the peak of the Kaskazi season, these dunes can swell to 15, even 20 meters high. That's taller than a house. And this happens every single year.
And we can actually put a number on that change. Studies show that the total volume of sand can fluctuate by up to 40% between seasons. The entire landscape is essentially breathing. It inhales sand during the strong Kaskazi winds and then exhales it during the weaker Kusi.
And this isn't just data on a chart, it's confirmed by the people who live there. A local resident, Ibrahim Hassan, puts it perfectly. He says he's watched this his whole life. The dunes grow tall during the Kaskazi, and then they get smaller when the Kusi comes. It's a rhythm that's just woven into the fabric of the community.
But there's a problem. This ancient, predictable rhythm is now facing a whole lot of uncertainty. Climate change could mess with the timing and the strength of the monsoons. I mean, a weaker Kaskazi or a stronger Kusi could completely rewrite the story of these dunes, changing everything about where and how this sand piles up.
And that's why, as climate scientist Dr. Amina Sharif points out, these dunes are so incredibly important. They act like these super sensitive indicators, kind of like a natural barometer for the health of the entire climate system. By watching them, we can actually learn about huge changes happening on a much, much broader scale. And of course, for the people who actually live here, the dunes are, well, they're everything. They're a landmark that helps fishermen navigate. They're a playground for kids. But they're also a constant challenge. Shifting sands can threaten roads, homes, and farmland. Living with a landscape this alive really requires a partnership between that deep local knowledge and modern science. So let's end with this thought. The dunes at Mambrui are this incredible reminder of just how responsive and alive our planet's landscapes really are. And it makes you wonder, if one small stretch of coast can change this much in just a single year, what other stories are our coastlines telling us right now about the future we all share?